this video, we're going to be talking about linear inequalities. So let's begin. Now, for this video, what we're going to go over is how to graph a linear inequality on a number line, how to solve a linear inequality expression, and then how to graph a linear inequality onto a coordinate plane. Right, so beginning, let's go over what a linear inequality is. So a linear inequality is an expression where any two values are compared by the inequality symbols such as greater than or less than. And these values could be numerical, algebraic, or a combination of the both. Right, now let's say we have the inequality x is greater than 3, right? So when placing this onto a number line, we're going to find where 3 is, that's right here, right? And x can be any value higher than 3, right? So there's technically an infinite amount of numbers x can be, right? Because there's an infinite amount of numbers greater than 3. So let's say we had x is less than 3, right? Then it would be the opposite, right? So we'd find 3, and x can be any value less than 3, or towards the left of 3, which again, this is also an infinite solution because there's an infinite amount of numbers that can be less than 3. Now, let's say we had the equation x is at least 3 or less, right? So when placing this onto a number line, instead of having an open point like I did before, we're going to have a closed point, right? This closed point symbolizes that we're including 3 within the line. And since x is at least 3, or 3 and less, we're going to go towards the left here, right? Now, if it's x is 3 or greater, we'll do the opposite, right? We'll have that closed point because we see this line underneath the greater than sign. So that means we're gonna go towards the right and include 3, right? And that's how you place linear inequalities onto a number line. Now, let's move to solving linear inequality expressions, right? So we're going to treat these kind of like solving linear equations, right? So we want to get like variables on each side. So with the first example, we see 3 plus c is greater than 10. And since c right here is the only variable, right, we're going to keep that there, and we're going to move the 3 over to the other side, right? And by doing this, we're going to subtract 3 from each side. So we're going to get 3 plus c minus 3 is greater than 10, right? Minus 3. Right, simplifying that, we're going to get c is greater than 7, right? And that would be our answer. Moving on to the next one, we have 10x is less than 50. So it's 10 multiplied by x. We're going to divide 10, sorry, from each side. So we're going to get 10x over 10 is less than 50 over 10. Right, when we simplify this, we're going to get x is less than 5. Okay, for this last one right here, we have 16p plus 27 is less than 3 minus 6p. So since we have two terms with that p variable, I'm going to try and bring this minus 6p over here and this 27 over here, right? So what I'm going to do is I'm going to add 6p to each side. So we're going to get 16p plus 27 plus 6p, and that's less than 3 minus 6p plus 6p. Right, simplifying that, we're going to get 22p, right, that's 16p plus 6p, plus 27 is less than 3, right, because minus 6p plus 6p is just 0. Now we have this 27, it's plus 27, so we're going to subtract 27 from each side. We're going to get 22p plus 27 minus 27 is less than 3 minus 27, right? Simplifying this, we're going to get 22p is less than minus 24, right? Because 3 minus 27 is equal to negative 24. Now we have the expression 22p is less than negative 24. I'm going to divide 22 from each side, so we're going to get p is less than negative 24 over 22, right? But remember, we can simplify this, so we're going to divide the numerator and denominator by 2, so we're going to get p is less than negative 12 over 11, right? So that's solving linear inequality expressions. We kind of treat it just like solving linear equations, so we're going to get like terms on each side, and we're going to reduce and reduce and reduce. Okay, moving on to graphing, right? Let's say we have the equation y is greater than 2x plus 2, right? Now first, we're going to graph the line y equals 2x plus 2 to see where it is, right? And remember, this 2 is the slope, which is rise over run, and this 2 right here, that's the y-intercept, so when x is 0, right? So I'm going to plot the y-intercept right here, right? And rise over run, since this is a positive slope, we're going to go up 2 and 1 to the right, so that's here. We'll do another one, up 2 and 1 to the right, that's here, and then we can make our line like so, right? That's what we get. Now, why we have the inequality y is greater than 2x plus 2. So whenever you graph something that is greater, we're going to go above the line, right? Because the y interval, or the y coordinate, is always going to be greater. So we can shade in everything here, right? Everything on top of the line, right? That would be within the inequality, right? But let's say we have, instead of y is greater than, we'll say that y is less than 2x plus 2, right? And now in this instance, what we're going to do is, instead of going on top, right, when you have less than sign, you go underneath the line. So everything in here, right here, everything underneath the line is the answer, or that's the shaded region for the linear inequality. Now we went over placing inequalities on a number line, how to simplify and solve linear inequalities, and we also went over how to graph a linear inequality, right? So you guys have any questions, feel free to comment down below. Please like this video and subscribe, and thank you for watching.